Hello and welcome to the History of Programming. My name is Mike Roslog. In the beginning there wasn't much, but there was a small spark of light. This light was an idea. There had to be a better, more accurate way to count and keep track of commerce. Once that light started to grow, the computer age was really born. What you might think about is, did it start in the 1940s? Actually, it started much earlier than that. Really, it started much earlier, back to around 2500 BC. That's when the computer age really started. And when we talk about computer age, we mean the thought process of how computers work and how we could manage and keep track of all things e-commerce. So when you think about it, the abacus was really the first mechanical calculator. It was used to help the blind people count. Think about it. It was really the first 508 compliant device. Plus, it was also used to explain ASCII with the use of numbers, letters, and symbols. So the concept that we actually had back in the old days is it was the first personal computer. So it came in, and this cartoon is great because there was the personal computer, there was the laptop, and then there was the handheld. And so really, when we started to think of how to control things for e-commerce and how to better count, is really when the process started for us to understand where this was going. So when you think about it, it's about hardware, not software. But at the beginning, that's how it started out. That's how people were trying to put things into a logical order. So let's look at a couple of dates that are important. 500 BC was the first use of a zero in mathematics. 500 BC, Sanskrit was actually created. 300 BC, the first description of the binary number system. 100 BC, the mechanical machine to predict astronomical events such as eclipses. So all of those things were actually built using machines so that we could go to one of those locations. But we still had a lot farther to go to get to where we were going. And this actual punch card is really what's important about what started to get us farther along in this concept. Around 60 AD, Huron of Alexander made a controlled sequence machine, which could be considered the first program. It basically had a control sequence that it could repeat. 850 AD was the first invention of cryptography, the ability to secure documents and communications. A lot more years later, a lot of math, a lot of logic, and a lot of machines. We actually get to 1642 when Blaise Pascal invented the mechanical calculator. In 1725 AD, the first use of punch card in looms was actually created. So as you can see, as we're going down the path, there's many things that are starting to happen that we can repeat, increase quality, understand the counting, and that's really where the basis of computer science comes from. And then something happened. It was the big leap, as they say. It was the thing that was going to change everything. And it was basically going to be the number machine. Charles Babbage, his analytical engine. Now, what was awesome about this analytical engine and why it was such a huge leap at the time was because it used the concept of programs. It stored in read-only memory, and it actually had a concept of a CPU. It used an early form of punch cards for storage and memory, and the machine could do conditional jumps, so an if-else. It also would have been powered by steam. There was only one small problem, though, with the machine. And it is a small problem, and I don't think it's one that's going to cause any problems. But it is a problem, and that it never worked. It never actually worked as it was predicted to work. But that never stops us anywhere, because I'm sure we've all heard necessity is the mother of invention from Plato. We've heard that throughout our childhood and our adult years, that if we need something, we will invent it and actually get there. So really where computers really started to take off was late 1800s, and it was around the U.S. Census. The actual counting of the U.S. Census took around 7 years to complete. Well, the concept was that the new census was going to take more than 10 years. Since you needed to do a census every 10 years by the Constitution, and it was going to take us longer to count it than the 10-year interval, something had to be done. So the Census Department needed a better method. And they actually created a contest for their employees to go out there and build something. And Herman Hollerith, census employee, won, and he did a tabulating machine. And it used basically mechanical relays to increment mechanical counters inside of it. Now, just as a side note, 1890, the U.S. Census counted 62,622,250 people. It was complete months ahead of schedule and far under budget, which ironically, Herman Hollerith also became the man who created the tabulating machine company, later to become known as IBM. So there is a rich history from that standpoint going into there. And keep in mind, when we think about computing, we're thinking really about counting. That's really where it's coming from, is how do we count, how do we do all these things? Even in today's graphical universe of 3D gaming, it's still all about the mathematics. So in 1943, the Z3 was the first operational programmable computer. Now, it had a binary setup, and it could do 3 to 4 additions per second and 3 to 5 seconds for multiplication. 1944, the automatic sequence controlled calculator came out. Now, I want to go into some of the stats for this. This thing was a huge mammoth machine. It was 51 feet long, weighed 5 tons, and incorporated about 750,000 parts. There was 3,300 relays, electrical relays on and off switches, and had 72 accumulators, which was each one an arithmetic unit. And it also could do a capacity up to 23 digits plus with the plus sign, plus or negative sign. So it was a massive, massive machine. But after that, we got into 1946, which was the ENIAC introduction, and it's one of the first totally electronic, valve-driven, digital programmed computers, 5,000 simple additions and subtractions every second. So as you can see, from 1943, 1944, 1946, the number of transactions per second multiplied exponentially as the world was getting more and more and more into the process of doing this. So if we look at the ENIAC, and if you're a programmer today and you think you have it hard, think again. The ENIAC could do complex operations. It could do loops, it could do branches, it could do subroutines. But it was programmed by manipulating a bunch of switches and moving cables around. 6 women actually did the programming, and there was a concept of debugging or validating using a single step of the machine. And here's a picture from the U.S. Army of actually Betty Snyder doing the programming on the actual box. So there was a little bit of excitement in that process